Hey everybody. So we're going to be looking at our Unit 1 test review today. This goes over almost everything we've learned this triad so far. So it's going to be a lot of, I guess, knowledge thrown at you, but please just keep up with me. I'm going to go fairly quickly and then you'll be able to kind of try some on your own. Okay, so the review starts out with just naming each visual representation with the correct vocabulary word. Okay, give it a name is basically what it's asking. Okay, I'm going to just remind you of all of these because I think it's worth just pointing out really quick. Okay, here we have these arrows on both sides. You guys remember this is considered a line. Okay, and that's all these are asking for. That thing's a line. Okay, this right here is an angle. All right, right here, we have two lines side by side. Here's the key information on these arrows. If you guys remember, arrows on two lines tell us that they are parallel. Okay, so we have parallel lines. Okay, take a look at this one. Okay, this we have two lines crossing one another, making a right angle. Okay, the correct answer to this one is not right angle. It's knowing that when two lines cross and create a right angle, they are perpendicular lines. So perpendicular. Okay, and we'll get in more to parallel and perpendicular lines in some other problems, but yeah. Okay, moving on from here, we have a single endpoint going off in one direction forever. If you guys remember, this is the definition of a ray. And on this one, we have two endpoints, all right? And this is when we have a segment, okay, or sometimes called a line segment, okay, but usually we leave off the word line. Okay, so yeah, just going through these kind of quick, stick with me. Okay, from here, it's asking us to find the distance between the 2 points. Write your answer in the simplest radical form. Okay, so first thing, distance. All right, we have to realize, okay, we are using the distance formula on this problem. Okay, this should be in your notes. Okay, and you can use your notes on this test. Okay, if this is not in your notes, highly recommend getting it in it. All right, but yeah, that's what we're gonna plug these numbers into. If you guys remember, the first thing we want to do on these problems is label our numbers. Okay, so this is going to be our first x, first y, and this is our second x, second y. Okay, now we know where these are getting plugged in for the distance formula. Okay, I'm just going to use d for distance equals the square root. All right, and we're going to plug it in to this formula here. Okay, x2 minus x1 squared. We'll start with that. Okay, x2 is a 2. Okay, and we have that built-in minus x1, which is a negative 4. Okay, that's being squared. And then plus doing the same thing with our y's. y2 minus y1 squared. Okay, y2 is a 4. Built-in minus y1 is a 3 squared. Okay, you guys remember when we did these in the past, look out for the double negative. It happens sometimes, but remember there's always that built-in minus sign. Okay, so always remember there's that, and then sometimes it's followed by a negative number, and sometimes it's not. Okay, so from here we can just do a little bit of math. I like to do both steps in one. So we know that 2 plus 4 is 6, and 6 squared gives me a 36. Okay, over here, 4 minus 3 is 1, and 1 squared, 1 times 1 is 1. Okay, and we're getting distance equals the square root of 37. Okay, here's the thing about this problem. They're asking us to keep our answer in the simplest radical form. Okay, if you guys remember in your calculator, if you click mode and go down, usually we want our calculator to be in classic mode. Okay, but if you want your radicals to be simplified, then you can put it into math print. Okay, the button right next to it. Okay, and if I type in the square root of 37 and press enter, it actually leaves my answer as the square root of 37. So here's the thing we need to realize. This is the simplest radical form. Okay, and for this test, this is what it's asking for. Okay, so not decimals on this problem. Okay, if you forget how to type in square roots or anything like that, please pause the video and talk to me or talk to someone around you. Okay, moving on from here, we're asked to find the midpoint between these 2 points. I'm not going to do this problem, but I'm going to remind you of the midpoint formula. Okay, if you guys remember, pretty straightforward. Midpoint formula, we add our x's, divide by 2, and we add our y's and divide by 2, and we get our answer. Okay, so yeah, I'm going to leave this to you. If you want to go ahead and copy the midpoint formula and try it out on your own, feel free to pause the video. I think that's a good idea. All right, moving along from here, they start to give us some segments and ask us to, find x, and then some of them want us to find the length of an actual segment. Okay, so this one says find the value of x given point K is the midpoint of segment JL. All right, so here's what I want to remind you. If K is the midpoint, that means it's being cut into 2 congruent halves. Okay, and that is our equation. I'm going to write the equation. I'm going to let you solve. Okay, but we know that 3x equals 4x minus 7. Again, I'm going to give you a chance to solve this on your own. On this problem, they just want you to find the value of x. So once you get x, you're good. You can move on. Okay. Getting into the next couple problems, these are also giving us segments. These are different. These aren't telling us we have a midpoint. They're giving us a value for the 2 small parts of the segment. And then in the directions, they're giving us a value for the entire thing. It's saying that xz is 9 plus 5x. Okay, putting that information onto this, I think, is really helpful because now we know what our equation is. We can add together the 2 small segments, 3x minus 9 plus 4x plus 6, okay, and that is equal to the entire segment, 9 plus 5x. Okay, I'm taking a look at this. This is asking us to find the value of x, so that's all it's wanting us to do. Okay, I think this is a good one to go over. So let's do this whole process. Okay, first thing I'm looking for is combining like terms on either side of the equation. On the left, I notice we have some x's, 3x and a 4x. I can just combine those together and get a 7x. Okay, remember, no need to do the opposite operation. They're already on the same side. Okay, I can also combine the negative 9 and the 6. Okay, and be careful with this. That's going to give me a negative 3. Okay, over on the right, nothing to combine with the 9 and the 5x. I'm going to bring it down. Okay, from here, before I can start solving, I need to get my variables to the same side. All right, you can move either one. I'm going to decide to move the 5x over to the left. Okay, so 7x minus 5x gives me a 2x. We've got this minus 3. Over on the right, these are gone. We have 9. Okay, and then basically a 2-step equation, adding 3 to both sides gives me 2x equals 12. Dividing both sides by 2, x equals 6. Okay, and on this problem, that's what they're asking us to do. Always double check your directions. Okay, because when you guys go to do number 6, which I'm going to have you do on your own, notice they're asking you to find the length of segment BC. So after you set up your equation on number 6 and you solve for x, you're then going to want to plug it back in to BC and actually find the length of that segment. Okay, so there's an extra step on number 6, but when you go to set it up, you're going to do the same thing. They're giving you the value of these 2 short segments, and they're also in the directions telling you that AC, the whole thing, is 10. Okay, so there's your equation. This plus this equals 10. Okay, go ahead and solve for x and then plug it back in. And again, you'll want to find BC, okay, which is this one right here. Okay, so I would recommend pause the video. Try that problem out. Okay, moving on from here, this question is actually asking us something that we haven't gone over yet. It's a really straightforward idea. So let's take a look at what it's asking. It says, give at least 2 examples of parallel lines, perpendicular lines, or lines that are neither. Okay, so let me just kind of give you I guess a crash course on this. This is something I'm sure you learned in Algebra 1 or maybe earlier. Okay, but let's start with parallel lines. Okay, if you guys remember, for 2 lines to be considered parallel, okay, they have to have the same slope. Okay, the same slope. Okay, and when we're talking about a line and its slope. This is normally written in slope-intercept form, okay, which is y equals mx and then plus b. Okay, here's the big thing. Slope is this number in front of x. Okay, b is the y-intercept, which isn't as important. Okay, it's more this number. Okay, and for two lines to be considered parallel, they have to have the same slope. Okay, so for example, if I have a line, actually, let's answer that. It says, what is needed? Let's point out, same slope. Okay, and it wants us to give, it says two examples. We're just going to give one example. Okay, so when you go to do this, okay, I'm going to write out an equation of a line, just any line in slope-intercept form. Okay, so y equals mx plus b, where m is a number and b is a number. Okay, so here's what it's going to look like. Y equals, let's say my slope is 5. So 5x, and let's say b really does not matter. It can be a positive one. Okay, when I go to write my other equation, it must have the same slope. Okay, so y equals, it also is going to have a slope of 5. Okay, here's the only thing. It can't be the exact same line. It can't have a b value of 1. So we just need to change it to anything else. Let's make it a 2. Okay, but again, the slope being the same is what makes those two lines parallel. Okay, so now let's move on to a perpendicular line. Okay, when it comes to perpendicular lines, here's what they need. Okay, these are two lines that have a slope that are opposite reciprocals from one another. Okay, opposite reciprocal. Let me remind you of what that is. Okay, so if we have a slope of, say it's a fraction, say it's 2 over 3. Okay, the opposite reciprocal, opposite means it changes its sign. If it's positive, it turns negative. Okay, so if this is a positive 2 over 3, it's going to turn into a negative. And the reciprocal is us just flipping the fraction. So if our fraction is a 2 over 3, it's going to turn into a 3 over 2. Okay, I'm sorry, there should be a minus sign in there. Okay, so those are opposite reciprocals. We change the sign and we flip the fraction. That's what it's all about. Okay, so if I were to go write a equation for two perpendicular lines, well, first of all, what do we need? Opposite reciprocals. Okay, slopes that are opposite reciprocals. Let's put slope in there. So let's say slope opposite reciprocals. Okay, and let's give an example. Okay, so here, what if one of my equations is y equals, let's make our slope a, I mean, we can literally use these same numbers that we used on the last one. Let's make one of them a 2 over 3. Actually, let's do it different so we can have another example to look at. Let's say our slope is a positive 1 over 5. Okay, we put x next to it. The y-intercept would just need to be some number. We might as well make it 1 again. Okay, here's the thing. My other equation, its slope needs to be an opposite reciprocal of positive 1 over 5. So it would then be a negative, and I would flip this to a 5 over 1. Okay, and then put x next to it. The y-intercept doesn't matter on this. It's all about the slopes. Okay, so I'm just going to make it the plus 2 again. Okay, so opposite reciprocals is what gives us perpendicular lines. Okay, change the sign, flip the fraction. Okay, for two lines to be considered neither parallel or perpendicular, you just need to have two completely just random slopes. Okay, so what is needed? I would just say, let's say different. I don't know if that's the best word. Different slopes. That's not the greatest, I think, like definition, because these are technically different slopes for perpendicular lines. Okay, but really just writing an example. Okay, so if I have one equation, let's say y equals 2x plus 1, my other one just needs to be a completely random slope. So let's say y equals a 5x plus 1, or it could be a 2. Remember, it's all about the slopes. Okay, these slopes are not parallel. They're not the same. They're not also not y opposite reciprocals. So they are neither. Okay, when you guys have the test, you're going to be given an example of 3 pairs of lines, and all you're going to have to do is be able to look at them and say, okay, those are the parallel ones, those are the perpendicular ones, these are the neither. Okay, so you won't be writing your own equations. It'll be a lot more straightforward on the test, just so you know. Okay, moving along from here. Okay, this gets into classifying angles as right, acute, or obtuse, and then giving the angle a name. I'm going to do one of these, and I'll have you guys try the other one. So I'm going to do angle number 1. Okay, so first thing, taking a look at this angle, I can see that this angle is less than 90 degrees. It's smaller than a right angle. Okay, and if it's less than 90 degrees, you guys remember, that's the definition of acute, less than 90. Okay, and while we're up here, let's just go ahead and remind ourselves, obtuse is greater than 90, and a right angle is exactly equal to 90. Okay, so if we're dealing with angle number 1, that thing is acute. Okay, and again, we can tell just by looking at it. Okay, let's name angle 1. Here's the big thing. On this one, we cannot call this thing just angle 1. We can't call it angle B. We need to go around the angle as we name it. All right, so I'm going to call this thing angle ABC. Okay, by the way, we could have also called this thing angle CBA. But remember, we have to start on a side, go around the vertex to the other side when naming an angle. Okay, so I'll have you guys try out number 2 here. Okay, by the way, you can kind of tell by just looking at this, this is going to be a angle that is greater than 90. So I'll let you figure out what that is and then give it a name. All right, let's keep moving along. From here, this is all about given angles, making equations, and solving, and some of them are asking us to plug back in. I'll help you set up a few of these equations, and then we'll kind of go from there. Okay, on number 9, they're giving us the value of the 2 angles, okay, which is great. Here's one thing they are giving us in the directions. They're giving us the measure of angle KLM. They're saying it's 140. KLM, that is the entire angle. So something to add to this problem is to show the whole thing is 140. Okay, really, we wouldn't need the degrees. Okay, and from here, we can make our equation. We know that x plus 100 plus 56 plus x equals the entire angle 140. Okay, I'm going to let you solve this problem. Here's the big thing to look out for. After you figure out what x equals, you're not done, because this problem wants you to find the measure of angle WLM. Okay, so after you find x, you'll plug it back into WLM. That's this angle right here. All right, and you'll find the measure of the whole angle. Okay, so for example, if you get x equals 2, 56 plus 2, you're going to get 58 degrees as the measure of angle WLM. Okay, taking a look down at number 10, this is saying find the measure of angle AOB given that OC bisects angle AOB. Okay, they're telling us this red line is bisecting this angle. Remember, when something is bisected, it's cut into 2 equal halves. We know that 7x minus 20 equals 2x minus 5. Okay, just like number 9, after you solve this, we'll need to plug it back in. Actually, let's do this one together. Okay, so first thing I'm looking at, nothing to combine on either side of the equation. Okay, so next step, I'm noticing variables on both sides. I'm going to move the 2x over to the left. Okay, so we got a 5x minus 20 on the left. On the right, we have a negative 5. Okay, and then from here, we can start solving. Okay, adding 20 to both sides. Okay, I'm getting 5x equals negative 5 plus 20. Careful, type it into your calculator if you're not sure. This gives me a positive 15. And then dividing both sides by 5, I'm going to get x equals 3. Okay, be careful. We're not done, right? We need to then plug it back in. It wants us to find the measure of angle AOB. Let's figure out what that is. Starts at A, goes around O to B. It wants us to find the measure of the entire angle, the entire thing. Okay, so let's off to the side. Let's start by plugging it into just one of these. Okay, let's plug it into this guy. So 2 times x minus 5. We just figured out what x is. It's 3. Okay, so 2 times 3 is 6. 6 minus 5. It looks like the measure of this angle is 1. Okay, so this is a 1 degree angle. So just to kind of put it in there, 1 degree. Okay, which is kind of like that. That's a little weird to me. I would maybe double check the math, but I think we're going to be fine. Okay, if we plug it in to the other one, 7 times 3 is 21, and 21 minus 20 is 1. Okay, so these are both 1 degree angles. And if we want the measure of the entire angle, we're going to add them together, and they're going to be 2 degrees. Okay, so again, I think kind of a weird answer to this one, but angle AOB equals 1 plus 1. AOB equals 2 degrees. Okay, let's keep moving. Okay, so most of these I'm going to leave to you, but I just want to remind you of some key things on this problem. These two angles make a 90-degree right angle. So just to remind yourself, these are going to add to 90. Okay, on number 12, these two angles make a straight line. Okay, they're going to add to 180. Okay, on number 13, these two angles are vertical angles. This angle and this angle are congruent. They're equal. Okay, so you will set those equal to one another when you go to solve. And notice all three of these just want you to find x. Okay, I'm going to leave those to you. This is a good time to pause the video. Try those out on your own. Okay, from here, we're getting into the parallel lines and transversals. All right, let's see. I think I'll do maybe one of these with you. Number 15, I'm going to do with you guys, but this piece of note right here is what to have in front of you during these. Remember, these problems is first identifying what type of angles do you have, and then what is the rule. Okay, so I'm going to leave 14 to you, but I think it's a good idea to put an arc through the two angles. Okay, and just to kind of give you guys a little hint on this one, it looks like these are going to be corresponding angles. Okay, and I'll let you go ahead and make some sense out of that. Let's take a look at 15 though. Okay, 15, we're dealing with this angle and this one. All right, here's what I notice. They're on the same side of the transversal on the interior of my two parallel lines. These are same side interior. Okay, what's the rule with same side interior? They are the weird ones. They add to 180. Okay, so there is our equation that we can make. So we know that x plus 109 plus x plus 89 equals 180. Okay, so let's do this math, and then we'll read the directions and make sure we're answering what they're asking. Okay, combining the x's, we have a 2x. We can also combine 109 plus 89. And it looks like we're getting a positive 198 equals 180. Okay, and then solving this, I've got 180 minus 198 gives me negative 18. So I have a 2x equals negative 18 divided by 2. Looks like x is going to equal negative 9. Okay, here's a question. Is that what they asked for? Name the angle relationship, which, by the way, we should point that out. These are same side interior. Okay, shown below. Then solve for y. Solve for y. What? We just solved for x. What are they talking about? Solve for y. Oh, y is actually right here. That's what they want for this problem. See, so what do? Well, we know that this angle and this angle are vertical angles. They're equal. If we can find this one, we'll know what y is. Okay, so there's my math. I can plug x right there. Okay, and if we do negative 9 plus 89, we can figure out that the measure of this angle is going to be 80 degrees. Okay, and if this is 80 degrees, this is 80 degrees. Okay, so that's actually our answer on this one. Y equals 80 degrees. Really easy to miss that and think, oh, well, we were solving for X and be done here. All right, so don't let this one trick you. Okay, cool. So moving on from here, last thing we're going to look at is a problem that's asking us to make a proof for parallel lines and transversals. Okay, this looks a little intimidating. I'll walk you through it and show you how this makes sense. Okay, so when you guys go to make a proof, first thing you can draw yourself two columns. On the left, we have our statements. On the right, we have our reasons. Okay, here's what we are asked to do. We are given parallel lines. By the way, this right here is the shorthand for parallel, if you didn't know. So they're telling us that we have parallel lines. That's wonderful. But here's what we were asked to do. Prove that angle 1 plus angle 8 equals 180. Okay, when we go to do these problems, this very first given piece of information is our very first statement. So saying that A is parallel to B, that's our first statement. Okay, our very final statement is going to be what they're asking us to prove. So on the very bottom, I'm going to write that angle 1 plus the measure of angle 8 equals 180 degrees. Okay, this is our goal, is to prove that that is true. Okay, well, how do we do that? We're going to make sense of our angles and give a reason for every single step we do. Okay, so first things first, we are making the statement that A is parallel to B. Why do we know that? Because it was literally given to us. Okay, the very first statement is always going to be given to us. Okay, so where do we go from here? That's the question. Okay, well, I'm dealing with angle 1 and angle 8. I'm trying to make a relationship between these two things. So I'm going to start with angle 1 up here. And I'm going to kind of try to work my way to angle 8. Okay, so here's what I'm thinking. I know that angle 1 and angle 5 are corresponding angles. Okay, and I know corresponding angles are congruent. Okay, so I'm going to just go ahead and write that fact here. I know that angle 1 is congruent to angle 5. Okay, and what's my reason? It's because they're corresponding angles. Okay, what else do I know? Okay, I've made some connections with angle 1. What about a connection with angle 8? If I were to look at angle 8, I know that angle 8 and angle 4 are also corresponding angles. They're also congruent to one another. Okay, so let's write that out and see, what we can do with this. Angle 4 is congruent to angle 8. Okay, why do we know that? Again, they're corresponding angles. Okay, here is where we have to make a logical leap. And here's what we can point out. Angles 1 and 4 are a linear pair. Okay, and that means they add to 180. Angles 5 and 8 are also a linear pair. They also add to 180. Okay, let's point that out. Angle 1 plus angle 4 equals 180. Okay, and on the same line, we can also say the same thing about 5 and 8. Angles 5 and angle 8 equal 180. Okay, why do we know that? Because they're a linear pair. Okay, so what's the connection we can now make? Here is the tricky part of this proof, is realizing that since angle 1 is congruent to angle 5, you don't have to draw these lines, but these angles here and here, they're congruent. We can literally swap their positions. So I can move angle 1 over to this spot. And if I did that, I would have that angle 1 plus angle 8 equals 180. And that's literally what my proof is asking me to prove. Okay, so that is what I've just done, is I've proved that angle 1 plus angle 8 does equal 180. Why do we know that? When we swap numbers and we make this relationship, it's called the transitive property. Okay, so transitive property. Okay, so yeah, proofs are tricky. I'm giving you a crash course on this. Do your best on these when you get to the test, okay? But it's all about just using the logic that we know to make our way to making a connection and, ultimately doing what they're asking us to prove. Okay? All right, everybody. So yeah, that's it for me today. I'll see you guys in class. Bye.